Hello geometry students, I hope that everybody is doing well. We are beginning a new chapter today and we are in chapter 6 and this is section 6-1 and we're going to be talking about how to classify polygons as well as how to calculate angle values from angle sum theorems. So we first have some definitions that we're going to talk about. And then we'll be able to get into some classification and then some calculations. So first of all, we have names for all these different polygons. And so we would like to be able to classify them. And some of them you're going to know, possibly all of them you're already going to know. So this is how many sides the shape is going to have, and this is what we're going to call it. So if it's a three-sided polygon, we know that that is a triangle. That one's easy. If it's a four-sided polygon, it is not going to be square. It's not going to be rectangle. It's going to be quadrilateral. Quadrilateral is generic, just meaning four sides. A five-sided shape or five-sided polygon is going to be a pentagon. A six-sided shape is going to be a hexagon. Seven-sided shape is a heptagon. Eight-sided shape, octagon. Nine-sided shape is a nonagon. And a 10-sided polygon is a decagon. So we'll be practicing using these words. We could also say six-gon, seven-gon like this. So we could also, just as an example, instead of saying hexagon, we could also say six-gon like that. And that means the same thing. But I'll just that was just as a little side note. Now, what exactly is a polygon and all of these parts of a polygon? Well, first of all, a polygon is an enclosed shape with at least three straight sides. So you have to have straight sides and it has to be enclosed. So a line is not an enclosed space, so we're not going to consider that a polygon. Now, there are parts of polygons as well. The side of a polygon is going to be the straight edge of a polygon. So the straight edge of a polygon. The vertex of a polygon is where two sides are going to meet at a point. So it is the point at which two sides meet. So down here in this image, this would be an example of a vertex, while this right here would be an example of a side. Now we also have different types of polygons. A concave polygon is going to be a polygon with vertices pointing inwards. While a convex is going to have all vertices pointing outwards. And you're going to see some examples of that here in a minute. Finally, a regular polygon is going to be something where all the sides and all of the angles are congruent. So it's a polygon with all congruent sides and all congruent angles. So we just covered a lot of vocabulary right there. A polygon is an enclosed shape made of straight sides. The side of a polygon is the straight edge, while the vertex is kind of like the corners or the points of it. Concave is going to kind of jut inward, while convex, everything is pointing outward. And a regular polygon is going to have all congruent sides and angles. And I'm going to tell you right now, regular polygon is something we're going to use a lot. We're going to use that definition plenty. So that's exceptionally important of all those words. So let's start applying these definitions just so we can classify some shapes. So in example 1, it says tell whether each figure is a polygon. If it is a polygon, classify it by its number of sides. So a polygon has to have straight edges and it has to be enclosed. So this right here has all straight edges and it is enclosed. So I'm going to say it's a polygon. Yes, polygon. And then we just need to count how many sides it has. So it has 1, 2, 3, 4, 5, 6. So because it has 6 sides, it is going to be a hexagon. Now in this next one, once again, we're looking for straight sides and is it enclosed? Yes, everything is straight on it and it is enclosed, so it is a polygon. Now I need to count how many, well, hold on. Yes, polygon. Now I need to count how many sides it has, so I'll start here. 1, 2, 3, 4, 5, 6, 7. So this has 7 sides, which means it's going to be a heptagon. Now we could go a step further with these and also describe this guy up here as convex and this guy down here as concave. We weren't asked to do that though, but that's another way that we could describe those shapes. In example 2, it says tell whether each polygon is regular or irregular and whether it is concave or convex. So remember, a regular polygon has all congruent angles and all congruent sides. So in example A, we have 4 angles, 1, 2, 3, 4, and they are all 90 degrees. So that's going to mean that all of the angles are congruent. Also, it has 4 sides, and all of the sides are marked with congruency symbols. So all the angles and all the sides are congruent, so yes, this is regular. Now we're asking, is it concave or convex? So notice how all of the corners are jutting outwards away from the shape, so it is convex. In example B, however, we do have all congruent angles, but we don't have all congruent sides. This side is obviously longer than, say, that side. So this is an irregular polygon. And then we got to ask ourselves, is it concave or convex? Well, this corner right here, as well as this guy and this guy and this guy, notice how the corner is pointing towards the inside of the shape. Because those are pointing inside, they're jutting towards the center. That is considered concave. Now we can draw down here. It says board work. And then it says, draw your own example of a concave polygon, a non-polygon, and a hexagon and label them. So it would be great for you to pause the video real fast and see if you can draw some examples on your own, but I'll give you a couple examples as well. So these guys are going to be concave, what I draw under there. This is going to be a non-polygon right here, and then these guys are going to be hexagons. Okay, so an example of concave might look like this. Notice how these are pointing outwards. It might also look like this. So, or sorry, I meant inwards. These corners are jutting towards the center of the shape. Usually concave shapes are going to look really strange. So all of these would be example of concave. Now we have examples of non-polygons. So something that we don't always realize would be a non-polygon would maybe be an oval. The reason an oval is not a polygon is because it is not composed of straight edges. And remember, a polygon has to be enclosed and made of straight edges. So another example of a non-polygon would be a squiggly line because it's not enclosed. And then another example of a non-polygon might look like that. Because this has an open space, it is not an enclosed triangle, so it is a non-polygon. Finally, we have hexagon. That can look like lots of different things. One example might be this. So 1, 2, 3, 4, 5, 6. So a hexagon just has to have 6 sides. So 1, 2, 3, 4, 5, 6. It might also look like this. Both of these are hexagons. A hexagon is only being classified by how many sides it has, while a concave polygon is only being classified by what direction the vertices are going. So you can have a convex hexagon or a concave hexagon, or you can have, I don't know, a concave pentagon and all that type of stuff. You can also have a regular convex hexagon as well. So there's lots of different ways that we can describe these shapes. Now that we've kind of talked about classifying, we're going to talk about how to calculate some things in polygons as well. So here we have the polygon angle sum theorem, and what this is telling us is how to calculate the angle total in a polygon. So the sum of the interior angle measures of a convex polygon with insides is n minus 2 times 180, where n is equal to the number of sides. So what this is going to tell us is, what this is calculating, what do the angles add up to? That's what this is answering right here. So I'm going to highlight that formula because we're going to use that quite a bit. So this is an important formula. Now, this is going to tell us what all of the angles add up to. What if I want to find the value of just one? Well, if I want to find the value of just one, so the measure of each interior angle of a regular polygon is going to be n minus 2 times 180 divided by however many angles there are. Because remember, a regular polygon is going to have all congruent angles and sides. So I'm going to put regular there, and I'm just going to remind you all angles are congruent in that type of shape. So this is just another formula that we're going to use. So this one is answering, what does one angle equal? That's what this one's answering. So this one's asking, what do all of the angles equal? This one's asking, what does one angle equal? And then our next one is the sum of the exterior angle measures, one angle at each vertex of a convex polygon is 360 degrees. So that 360 degrees is telling us the outside angles add up to 360, and you're going to, so I'm going to highlight the sum of the exterior angle measures is 360. There we go. You're going to see what that looks like here in just a moment in example 4, but one thing at a time. So let's apply this. We've got 3 pieces of information that we can use now. So we have n minus 2 times 180. That guy's going to be what the total sum of the inside angles are. This guy is what the value of one angle is, and this guy is what the value of the outside angles are on polygons. Okay, so in example 3, it says find the measure of each interior angle in pentagon ABCDE. So we have A at 35C, B at 18C, C at 32C, D at 32C, and E at 18C. The issue is we need to figure out what do all of these angles add up to. So just like in every triangle, the angles add up to 180. We can figure out what the angles will always add up to in every pentagon as well, because this has 1, 2, 3, 4, 5 sides. To figure out what the total is going to be, we're going to plug that into this formula, where n represents how many sides there are in that shape. Excuse me. So to figure out the total, I am going to say, so I'll label total is going to be 5 minus 2 times 180. Well, 5 minus 2 is 3, and then 3 times 180 is going to be 540. So I now know that A plus B plus C plus D plus E has to equal that total of 540 degrees. So let's set that up. I have, and I'll just start at A and work my way around. I have 35C plus 18C plus 32C plus 32C plus 18C equals 540. So I took these 5 angles and I set them equal to 540. And the way I got that 540 was by using this formula right here, which tells us what do the angles add up to. Okay, now I'm just going to start solving like I would any other equation. So 35C plus 18C plus all this stuff, because these are all like terms. All of these are going to add to 135. So I have 135C is equal to 540. Now I want to divide by 135 on both sides. And I'm going to get C is equal to 4. Okay, that's awesome, but I need to go a step further. I'm not trying to figure out what little c is. I'm trying to figure out what each and every angle is. So angle A is going to be 35 times 4, which is 140. Angle B is going to be 18 times 4 because it's 18C and C is 4, so 18 times 4 is going to be 72 degrees. Angle C is 32 times C, so that's 32 times 4, or 128. And then D is the same, so I know angle D is equal to 128. And angle E is the same as angle B, so I'm going to say that is 72 degrees. And that's my answer right there. Okay, so this, one more time, I used this top formula right here to tell me what do all 5 angles in that pentagon add up to. When I figured that out, then I added them all up and I set them equal to that value. I solved for the variable and then I plugged that variable back into each and every angle. In example B, it says, what is the sum of the interior angle measures of a heptagon? Well, a heptagon, first of all, 7 sides. So we need to know that. And what it's asking us is, what is the sum of the interior angles? All I've got to do is use my formula right up here. So n represents the number of sides. I'm going to say 7 minus 2 times 180. Well, that's 5 times 180. And when I plug that into a calculator, I am going to get 900 degrees. I don't need to divide by anything because it's asking for the sum, and the sum means the total of all the angles. So if I had any shape that had 7 sides, exactly 7 sides, any polygon, those interior angles would add up to 900 degrees. In example 4, we're talking about exterior angles, though. So it says, find the value of B in polygon FGHJKL. So this is polygon FGHJKL. And I'm trying to figure out, what does B equal? Well, first of all, what I want you guys to notice is there is one exterior angle at each vertex. So here's vertex J, and here is the exterior angle with it. Here's vertex K. It only has one exterior angle. We're not also including that guy, right? Or there's not another line jutting out here and giving us another angle. There's just this angle and that angle, and it goes all the way around. Now, I have to be able to distinguish, is this on the outside of the shape or the inside of the shape? All of these are on the outside of the shape, so I do not want to use this formula because this formula tells me about interior angles. Instead, I want to use this property right here that lets me know, oh, the exterior angle measures always add up to 360. It doesn't matter if the shape has 3 sides or 20 sides. The outside angles will add to 360. So that's what I'm going to do here. I'm going to take all my outside angles, add them up, and set them equal to 360 degrees. So I'll just start at F and then work my way around the polygon again. So I have 15b plus 18b plus 33b plus 16b plus 10b plus 28b equals 360. Let me make sure I got all of them. 1, 2, 3, 4, 5, 6. I'm missing one. I've got 15, 18, 33, 16, 10, and 28. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, that's because I accidentally counted how many sides there were wrong. My apologies. So yes, I have everything here. So now I'm going to add all these up because these are all like terms. So I'm going to get 15 plus 18 plus 33 plus 16 plus 10 plus 28. That is going to get me 120. So I have my 120b is equal to 360. Divide by 120 on both sides. And I have b is equal to 3. Now, notice in the directions it said find the value of b in polygon FGHJKL. So I am done because I did in fact find the value of b. In example B, it says, what is the measure of each exterior angle of a regular octagon? Okay, so in a regular octagon, I am going to have 8 angles, which means I'm going to have 8 exterior angles as well. And because it's regular, all the angles on the inside and the outside will be congruent. All interior angles are congruent, and all exterior angles are congruent. So if I'm not the best at drawing octagons, so here's my octagon. If I were to extend a little bit at each vertice, this angle plus this angle plus this angle plus that one, all of those are going to add to 360 still because we're talking about exterior angles. So that's where I'm getting my 360. And I know that they're all going to be the same size because it's a regular polygon. So all I have to do is take 360 divided by 8. And when I do that, I get 45 degrees. So in this instance, if it's a regular octagon, each individual exterior angle will be 45 degrees. That's all we have for today's video. I hope you have a great night, and I'll see you soon.